Hey guys, what's up everyone? How are you people doing? Hoping that all of you guys are doing good and taking very good care of yourself. Welcome back to today's session, people. This is going to be the third session of motion for CBSE ninth. And before we get started, let me introduce myself. My name is Anoop. For those of you who do not know me, I'm a Master Teacher of Science here at Vedantu. A very warm welcome to all of you guys out there, and hoping that you guys are enjoying this series wherein we are talking about all the chapters regarding CBSE 9th, 10th, as well as ICSE 10th as well. So in today's session, guys, our focus is going to be on understanding distance and velocity time graph. In the sessions before this, we had talked about distance, displacement, speed, average velocity. We talked about acceleration. We saw some numericals based on acceleration as well. Today, our focus is going to be on understanding distance and velocity time graph. But before we get started, as always, we're going to start off this session also with a quote, just to like inspire ourselves to do better. And the quote for today is this, guys: success is walking from failure to failure with no loss of enthusiasm. So these were said by Winston Churchill. So I don't know if there's anything that I can add to this, but yes, guys, yes, you always have to be ready to, you have to always be ready to fail and pick yourself back up and then move forward. And that is something that is an attitude that you have to build up, and it's not something that comes up in 1 or 2 days. It takes a lot of time. But yes, with that in mind, let us get started with today's session, guys. So like I told you, this is going to be on distance and displacement time graph, and graphs are something that is more colorful to work with. So let's talk about that. So people, before we get started, in the last session, I had given you a homework. First of all, a round of applause to all those guys who did the homework. Hats off, people. Keep up the good work. The question was this: a truck traveling at 54 km per hour slows down to 36 km per hour in 10 seconds. Find the retardation in meter per second. So the question was basically to find out the retardation or the negative acceleration or deceleration, if you want to call it like that. That's also fine. So you're supposed to find out what is the retardation in meter per second. First thing first, guys, it might seem like a direct question, but no, it's not just subtraction of the values that is given. Because if you remember the formula of acceleration or retardation, acceleration is equal to velocity, final velocity minus initial velocity divided by time taken. So in this case, first thing first, make sure that all the units are same. They've asked you to put, find it in meter per second, but your initial velocity as well as final velocity is given in kilometer per hour. So first job is to convert the units. Now this is the thing that you have to practice again. Make sure that your exams also look at the units first before you just directly put in the values and start writing the answer. Make sure that you change it and then put down the equation. So in this case, guys, if I want to convert 54 km per hour to meter per second, so it is the value is 54 into 5 by 18. So that's how if you want to convert to meter per second, it's 5 by 18. So what do you get? 2, 9, 18, 2, 2, 4, 2, 7, 14, 9, 3, 7, 27. So 5, 3 is 15. So that is 15 meter per second. For the second one, that is 36 kilometer per hour in terms of meter per second is again 5 by 18. So 18 2 is 36, so 5 to 10, so that'll be 10 meter per second. So in terms of meter per second, that's 15 meter per second and 10 meter per second. They've given you the time taken also, but in terms of seconds, that is 10 seconds. Find out the retardation. It's pretty simple. So you have to final velocity is 10 meter per second, initial velocity is 15 because the body is slowing down, right? So that is the final velocity. It's 36 km per hour or 10 meter per second, and the initial velocity is 54 km per hour or 15 meter per second. Divided by the time taken, that is 10. So that is minus 5 divided by 10, which would give you basically minus 0.5 meter per second square. So that will be the retardation. Congratulations, all those who gave the right answer. It is actually a pretty straightforward question, but a little twist. That's all you have to straighten out. Anyway, so these are the winners for today. We have Sureka, Sachin, Vilas, Raghav, and Senthil, and Shankarappa, and also Sandeep. Congratulations, guys. I hope to see more such amazing response from you people. Keep up the good work and keep learning. That's it. All right, well, that's it, guys. Let us get started with distance time graph. So first thing we're going to do is we're going to understand about distance time graph, then we'll understand a little bit about displacement time graph, and then we'll move on to velocity time graph as well. So let's start with distance time graph. Let's start with an example. So let's say this, guys. Let's say a person is running a 100-meter race. All right, so I am going to check his time taken to cover that 100-meter distance. So I'm going to take three intervals, let's say. So I'm going to take an interval between 0 to 20 meters, 20 to 50 meters, and 50 to 100 meters. So I'm going to say that he covers the first 20 meters, that is 0 to 20 meters. He covered it in 10 seconds, and the next 20 to 50 meter, sorry, he covered in 15 seconds, and then the remaining 50 to 100 meter he covered in 25 seconds. So I'm checking what is this distance covered at certain duration of time, right? So 10 seconds, 15 seconds, and 25 seconds. Now what I'm going to do is that I'm going to represent that in the form of a table. So time on one side, on one column, and distance on the other column. So time is 0, displacement is 0, distance is 0, sorry, because the person is in the state of rest. After 10 seconds, I see that he has covered a distance of 20 meters, and after 15 seconds, I see that he has covered a distance of 30 meters, because if you look at it, it's 20 to 30, 50 meters. So basically, he's covered 30 meters in 15 seconds, and the next 50 meters he has covered in 25 seconds. So this is what I'm going to get. Now, remember the formula of speed. What is the formula of speed? Remember, speed is equal to distance by time. We've already seen that, right? Speed is distance by time, where d is distance, s is speed, and t is the time taken. So what I'm going to do is that I am going to find out what is the speed at all these three intervals. All right, so very simple. For the first case, if I want to find out the speed, so I'll take it as S1 is equal to distance is 20 meters, time taken is 10 seconds, that's 2 meters per second. For the second one, S2 is basically he's covered a distance of 30 meters, 50 minus 20 is 30, divided by time taken is 15 seconds. So again, it'll be 2 meters per second. For the third one, S3, what am I going to get? It's 50 meters, 100 minus 50 is 50, 50 divided by 25 is again 2 meters per second. Interesting. 2 meters per second, 2 meters per second, and 2 meters per second. So that means that the body or the person is running at a constant speed, which means that you can say that the body is at uniform motion. Now, if I want to draw a graph, all right, I'm going to draw a graph based on the information that I have. So I'm going to draw a simple graph over here. My graph is a little weird, but still, you get the point. So I'm going to represent the y-axis as distance. So this will be distance, and this is going to be time taken. It's going to be time in terms of seconds. This will be in terms of meter. All right, so I'm going to draw out a graph. So I'll just take any interval. I'll take it as 0 to, let's say, 10 and 20 and 30 and 40 seconds. Distance covered, I'll take it as 10, 20, 30 and 40. All right, 10, 20, 30 and 40. So what I'm going to do, I'm going to plot the graph, all right? So I'm going to plot out the graph, and I get that this is what the graph looks like. Now, here they've taken different intervals. So because you can either take it as 10, 20, 30, 40, 50 until 100, or you can take it like this 0, 25. So the difference is 25. So each centimeter has a value of 25 meters, 25, 50, 75, 100, and time taken is 10, 20, 30, 40, and 50. Now, when you plot the value, what you're going to get is a straight line, which is basically, you can see it as a linear graph. Now, from this, what are the things that you have to take away is this. When you talk about a distance time graph, distance should always be represented in the y-axis. When you say a distance time graph, distance is in the y-axis and time would be in the x-axis. So if I calculate this, we have already calculated the speed. We saw that his speed is 2 meters per second at each and every time interval. We saw that his speed is 2 meters per second, which we came to the obvious conclusion that the speed is basically constant. So I can say that the body is in uniform motion. Now, what we did before was find the speed by using the formula, that is speed is distance by time. What if I want to find out the speed from the graph? Yeah, what if I want to find out the speed from the graph? So in this case, what should I do? Now, in simple words, I'll just tell you one word, and that is nothing but slope. Find the slope of the graph and you'll be able to find out the speed in a distance time graph. Now, the question that you might ask is, sir, how do I find out the slope? Now, there is a formula to find out the slope, guys. So the slope is generally represented as m, which is basically calculated by using this formula, that is y2 minus y1 divided by x2 minus x1. Now, what are these y2, y1, x2, x1? These are nothing but the coordinates that you're going to take. For example, guys, let's say that I want to find out his speed between, let's say, 10 seconds and 25 seconds, all right? So 10 seconds and 25 seconds. This is 25 and this is 10 seconds. I'm going to find out his speed. So what I'm going to do is that I'm going to take this as x1 comma y1. So these are the two coordinates, x1 comma y1. So what is the value of x1? This is the x-axis, so it's 10 comma this I think is around 20 if I'm not wrong. So we'll take it as 20. All right. And for the y-axis over here in this it's 50, and for the x-axis it's 25. Now this will be y2 x2 comma y2, and this will be x1 comma y1. Put down the values in this, that's it. So if you were to do it, if you have to calculate it, so in this case y2 is 50, y1 is 20, x1 is 25 minus x2, x2 is 25 and x1 is 10. So if you calculate it, what are you going to get? You're going to get 20, that's 40, if I'm not wrong, not 40, sorry, 30 divided by 15, which again gives you 2 meters per second itself. As simple as that. So you take any 2 points like this on the graph, use this formula y2 minus y1 divided by x2 minus x1, you would get the speed of that particular body. So if you're given a graph, do not use the formula speed is distance by time, but rather use the formula slope so that you're able to give the right answer, because your teacher expects you to use the formula, and that's why they give you the graph. If not, they wouldn't have to go through all that trouble to give you a graph. So make sure that you use the formula to make to get the right answer. Alright guys, so one thing that you have to understand is this, guys. If it's a uniform motion, that is if the speed is constant, then you represent it as a straight line, a linear line in the distance time graph. If it's a non-uniform motion, then the graph is going to be curved. Like for example, let's take another example for that. Let's say a person is running again 100 meters. So this time I'm going to check how much time did it take for him to cover 0 to 30 meters, 30 to 60 meters, and 60 to 100 meters. So in this case, I see that the person covers 30 meters in 30 seconds, and another 30 meters in 43 seconds, and another 40 meters in 55 seconds. That is 30 to 60 meters in 43 seconds, 60 to 100 meters in 55 seconds. So if we again represent the value in the form of a table, so speed, time, and distance. So 0, 0, and 30. In 30 seconds he covered a distance of 30 meters. In another 43 seconds he covered a distance of another 30 meters, and then another 40 meters in 55 seconds. So in this case, if you use the formula once again to find out the speed, you would find different values. For the first one, you'll get it as 1 meter per second, and for the second one, you would get it as 43 divided by 30 divided by 43. Whatever the value is, that is what you're going to get. So what I'm trying to say is, basically, you're going to get different values. So for this, if you were to plot out a graph, again, the same thing, distance on the x-axis and speed, time on the y-axis. So this is distance. So I'll write it like this so that you're able to understand this. So it's distance. This is time taken. So if you find out if you plot out the values, you will get a graph, which is not exactly a straight line. You see that it's basically a curve. So if the distance time graph, or if in case the body is moving at non-uniform motion, then the distance time graph is going to be a curved line, but rather not a straight line. So if in this case, like I told you, if you were to find out the speed using the formula speed is distance by time, for the first one you'll get it as 1 meter per second. For the second one, the second time interval, you would get it as 1.39. For the third one, you get it as 1.81 meter per second. So basically the speed is varying, and that is why you see that the graph is also a curved line. So from this, you can come to the conclusion that for a non-uniform motion, the distance time graph is going to be a curved line and not a linear line. Simple as that, guys. Now that you've understood this, let's take another example. All right, so this is person number C. We talked about person number A, who's running with uniform velocity or uniform motion. Second one was non-uniform motion. In the third case, let's say that the person is moving, or is in 2 second time. Let's say that he covered a distance of 6 meters, and then he got tired and he stopped moving completely. So in this case, how do I represent in a distance time graph? So let's say this, guys, again, distance time graph. So distance is in the y-axis, and this time would be in the x-axis. So this is distance, this will be time, right? X-axis, y-axis, right? So in this case, if you were to plot the graph, you would get a graph which looks like this. Now, why does it look like this? Here's the thing, guys. In 2 seconds time, he covered a distance of 6 meters. Now, if I check his distance after 4 seconds, it'll be still 6 meters, because he has not moved from that place only, So he is standing there. At 6 seconds time, again, he has covered a distance of 6 meters itself. 8 seconds of 6 meters. He's not moving. He's just standing in that same place. So in those kind of cases, if it's a distance time graph, then what you're going to get is basically a line which is parallel to the x-axis. And if in case you find a graph in which the graph is parallel to the x-axis, then you can directly come to the conclusion that the body is in the state of rest, or the body is stationary or not moving. So in this case, you see that he is not moving after 6 meter distance. Simple as that. Now to talk about displacement time graph. So all this while, guys, we have talked about distance time graph. Now the only thing this different about displacement time graph is that in a displacement time graph, if you find out the slope, you're going to find out the velocity. You'll get the velocity. Same formula, everything is the same, just that if you find out the slope in a displacement time graph, you're going to find out the velocity. So if you remember the formula, m is equal to y2 minus y1 divided by x2 minus x1. So if you find this value, you would actually get the velocity. In a distance time graph, that would give you the speed. In a displacement time graph, it would give you the velocity. As simple as that. Okay, so all that you have understood right now, let me just sum it all up. What did we see so far? In distance time graph, the slope of the graph gives you the speed. The straight line represents a uniform motion. A curved line represents a non-uniform motion. And an object which is in stationary basically means that the line would be parallel to the x-axis. It will be a horizontal line parallel to the x-axis. Apart from that, the last thing that we saw in a displacement time graph, if you find out the slope, you would find out the velocity. Simple as that. All right. Now that you've understood this, guys, let's do some questions. Obviously, we have to do some questions also. Let's try to do some questions, and then we'll move on to understanding about velocity time graph. All right. So here are a couple of the questions, guys. Here's the first question of the day. Here it go. The distance time graph of two cars is shown below. Find out which car is faster. Now, I want all of you guys to write down whatever is the answer in the comment section below. Pause the video. Give me the answer. I don't want anyone to copy my answers. I want you guys to try it out and let me know what the answer is. All right. So for this question, your options are these. Is it car number A, car number B? Can't say, or both have the same speed. So this is what the graph looks like. You're supposed to find out which car is faster. So one way to do it is, guys, by doing it mathematically. You can take any 2 points, find out the slope. That is acceptable. For example, let's say that I take these 2 points. So these 2 points for this one, and let's take another point. Let's say I take this point. All right. So I can find out the slopes like this. All right. So if you find out the slopes, let me take another color to represent the value for this one. So for this graph, I'm going to take this one. So yes, if you find out the slopes, you will be able to clearly find out that which one is faster than the other. That's one way to do it. But I would suggest an easier way to do it. Here's the thing, guys. Just remember this. Whichever has a much more steeper line or a steeper graph, that is obviously going to be much more faster. So if you just look at it, you see this. In, let's say, 2 hours time. In 2 hours time, this car has traveled a distance of 20 kilometers. Whereas at the same 2 hours time, this car has traveled a distance of 40 kilometers. So obviously it's faster. No, if the time is constant, whichever covers the greater distance, that means that is faster. Simple as that. So whichever is steeper, whichever graph is steeper. Steeper means more is the angle. Whichever is the more steeper one, that would be the car which is faster. So in this case, it'll directly be option number A. That's all. Or you can find out the slope, and you'll still see that car number A would be the faster one. So if you find out the slope, you can still see that option number A would be the right answer. Simple as that. Car number A is much more faster than car number B. So like it's much more easier. You don't have to waste your time. If in case they have not asked you the calculation, just remember this: the steeper the curve, the faster the car. Simple as that. Second question, guys. This is an interesting one. The graph shows the position of a body at different times. Calculate the speed of the body from A to B, from B to C, and from C to D. So you're supposed to find out what is the speed between these 3 points. Your options are like this. You have 1 centimeter per second, 0 centimeter per second, and 1.5 centimeter per second, 2 centimeter per second, 0 centimeter per second, and 1 centimeter per second, 1.5 centimeter per second, 0 centimeter per second, 1 centimeter per second, or 1.50 and 0 centimeters per second. So this is the graph. You're supposed to find out what is the speed once again, guys. So yes, guys, to solve this question, you just have to use this slope wala formula. Very simple. I'm going to do the calculation over here itself so as to avoid any sort of confusion, because again, going back and forth would be a little hard. So let me just do it over here. So for this, I would start off with A comma B. So what is the coordinates of B? Let me just write that down first. So it'll be 4 comma 4. On the x-axis also it's 4. On the y-axis also it is 4 itself. So I'll get as 4 comma 4. On the the coordinates or the coordinates of A is basically 0 comma 0. So again, using the formula for the first one, A to B, it is y2 minus y1 divided by x2 minus x1. Y2's value is basically 4 and y1 is 0. X2 is 4 minus 0. Once again, you get a 0 meter per second. Simple. So the answer, sorry, not 0, 1 meter per second. That will be the answer for the first one. 4 divided by 4. So it'll be 1 meter per second. For the second one, however, if you talk about B and C, so these are the coordinates for this one. So you have x coordinates are 4 comma 4. Sorry, the coordinates at B are 4 comma 4 on the x-axis and y-axis, and for C it is basically 7 comma 4. So in this case, if you were to substitute the values again from I'll just write it over here, that is B to C. What will be the answer? That is x2 is basically sorry, y2 is basically 4 minus 4. X1 is basically, x2 is 7 minus 4, so that will be basically 0 divided by 3, which would give you 0 meter per second. Simple as that. So if we talk, so again, if it's a straight line, you clearly know that if it's a straight line, if it's a horizontal line parallel to the x-axis, I told you that the body is in the state of rest. So between 4 to 7 seconds, the person was in the state of rest itself. So basically it'll be 0 meter per second. For C to D, once again, find out the coordinates over here. So this would be basically this is 9 comma I guess it is 7, so I'm going to take it as 7 for now. So 9 comma 7. So for I'm just gonna write it over here. I know it's a little clumsy, but there is no graph given on that. That is why I had to do it over here, crunch it all up in one place. So C to D, you're supposed to find out what is the slope. Once again, x2 is y2 is 7 and y1 is 4. X1 is x2 is 9 minus 7, so that's 3 divided by 3 again, 7 here, sorry, 3 divided by 2, so that would give you 1.5 meter per second. As simple as that, guys. So the answer is 1 meter per second, 0 meter per second, and 1.5 meter per second, which is option number A. So the answer to this question is option number A, guys, which is 1 meter per second, 0 meter per second, and 1.5 meter per second. Simple as that. All right, guys, so that is the answer for this one. Now moving on to the next topic, which is understanding about velocity time graph. So let's take an example for this one also, for velocity time graph. So let's say that there's a body moving with a certain velocity, and I see that at time is equal to 0, his velocity is 4 meter per second, time is equal to 1 second, his velocity is 10 meter per second, and at 2 it's 16, and at 3 meter per second, at 3 seconds it's 22 meter per second. So for this values, if I were to plot out a velocity time graph, first of all, from the name velocity time graph itself, you can figure out what exactly is the graph all about. So when you have a velocity time graph like this, first of all, understand that this means that the x-axis would be time and y-axis would be velocity. So the exact same thing how we did it for distance time graph. If you were to plot out a graph for all these values, this is what the value would look like. So that is 10 meter per second, 0.0,4, 1, 10, 2, 16, and 2, 22 as well. All right. Where the first one is 0,4, 1, 10, 2, 16, and 3, 22. So if we look at it, it's again a straight line. Now, in a velocity time graph, if the line is a straight line or a linear line, you can say that the body is in non-uniform motion, but with constant acceleration. Because what is acceleration? Acceleration is the word, where a rate of change of velocity. So again, if you find out the slope in a velocity time graph, that will give you the acceleration. So if you use the same formula, that is m is equal to y2 minus y1 divided by x2 minus x1, you would actually get the acceleration in a velocity time graph. You're going to get the acceleration. Whereas if you talk about a distance time graph, that is going to yield you speed. In a displacement time graph, that is going to give you velocity. In a velocity time graph, the slope of the graph is going to give you the acceleration. So in this case, you can come to the conclusion that the body is in non-uniform motion because obviously the velocity is changing, but with constant acceleration. Because if you find out the acceleration in this case, it would be basically constant. So if you take 2 points, let's say I take these 2 points, so y2 is basically 16 minus 10 divided by x2, so m is equal to and x2 is 2 minus 1, so that is basically 6 by 1, which would give me 6 meter per second. So 6 meter per second square would be the acceleration in this case. Alright guys, so that is the conclusion that you can come to with this. With that said, if you want to talk about non-uniform motion with variable acceleration, let's take an example of that case. So imagine there is a kid walking on a straight line. So you see that velocity at time is equal to 0 meter per second, but at time is equal to 5. After 5 seconds, you see that his velocity is 10 meter per second, and after 5 more seconds, you see that his velocity is 15 meter per second. So in this case, obviously the velocity is not changing at a constant rate; is obviously changing at a variable rate. So in this kind of case, you see that the acceleration would also be variable, and if the acceleration is variable, so if you represent this values as a graph, the graph would definitely not be a straight line. You see this? If it's not a straight line in a velocity time graph, that means the body is in non-uniform motion, and most importantly, it is going with variable acceleration. But more about this, you'll study this in your higher grades wherein you'll be solving problems based on that. For now, this is just the base that you have to touch. Okay, with that said, now one more thing that you have to understand is basically finding out the displacement in a velocity time graph. So if you have a velocity time graph and if you are asked the displacement, so you're supposed to find out what is the displacement of the body, it's actually straightforward. If you find out the area under the curve or the area of the graph, you would be able to find out what is the displacement of the body. For example, if this is the graph, the body is moving with a constant acceleration at the first, then you see that the body is decelerating as well. So in this kind of case, if you want to find out what is the displacement of the body, find out you see this, they have divided into 3 different areas. So find out the area of this one, add this one as well, find out the area of this one and the area of this one as well. So area 1 plus area 2 plus area 3 would actually give you what is the displacement of that particular object. So in a velocity time graph, if you find out the area under the curve, that would basically give you the displacement of that particular graph. As simple as that. Okay, so with that said, now what do we understand so far? In a velocity time graph, the slope gives you the acceleration. Acceleration is not always uniform motion. So if it is in this case, if the graph is basically a straight line, then you can say that it's uniformly accelerated. If the graph is not a straight line, then it is variable acceleration. And apart from that, we also saw that the area under the velocity time graph represents the displacement. That is what we saw in today's session. So with that said, please, once again, we're going to solve some questions now based on what we have seen and try to absorb what all we've seen so far. So here's the first question: is the velocity time graph of two bodies A and B traveling along the x direction are given. Which body has a greater acceleration? So A and B are given. You're supposed to find out what is the you're supposed to find out which one has a greater acceleration. So your options are body number A, body B. Both of them have the same acceleration or cannot be predicted. The answer to this question is actually pretty straightforward. Once again, because the graph is much more steeper, if you find out the slope of this graph, you can clearly see that this is going to be greater. The slope of A would be greater than the slope of B. So you can come to the conclusion that the option number A or the body number A has a greater acceleration. So if you find out the slope, so in this case it'll be basically slope would basically be x by t. So this x by t for body number A would actually be greater than the slope of body number B. So if you find this out, if you directly put it, you'll get the answer as option number A. So again, you can use the simple logic that I gave you. The steeper the curve, the body is accelerating at a faster rate. In the case of distance time graph, I told you that it is moving much more faster, or the speed is much more greater. Simple as that. Okay, so the answer to this question would be option number A. Moving on to the second question: which of the following area represents the displacement in a velocity time graph that is given over here? So you're supposed to find out which area are you supposed to find out the displacement of this particular body. So the body is moving from A to B with a basically constant acceleration, or constant acceleration. So you're supposed to find out non-uniform motion but constant acceleration. You're supposed to find out what is the displacement, or which area that you're supposed to find out the displacement. Is it ABE, or your options are ABE, ABCD, AECD, AOC, or ABCD? The answer to this question is actually pretty straightforward, guys. So if you find out what is the area, this entire area, if you find out, that would give you the displacement of this particular body. So because the body is not starting at a zero, his velocity, initial velocity itself was 2 meters per second. So that means he's already covered a certain distance. So he has already covered the displacement is also not zero. So we find out the area of AD, B, C, you'll be able to find out what is the displacement of that particular body. Simple as that. So the answer to this question is basically A, B, C, D's. That is what we just saw right now. In this case, A, B, C, D. So clockwise direction. Simple as that. That is the answer, guys. With that said, moving on to the next question. Here it is. Find out the total displacement of a person if his velocity time graph is as given below. So they've given you the graph. You're supposed to find out what is the total displacement. So once again, guys, it's actually pretty straightforward. Find out the area of this one. Find out the area of this one. Find out the area of this one. Add them both up, it'll give you the displacement. So your options are this: 27 meters, 30 meters, or 36 meters. So I am going to solve this question for you guys. For the first one, guys, so the first one, to find out the area of the first one, it's basically a trapezium. So what you can do is basically divide this trapezium into a right angle triangle and a rectangle. Find out the area of the triangle and the area of the rectangle and add them both up. That will give you the answer. Or you could use the formula of area of trapezium, which is nothing but the area of trapezium is, so the area of, in this case, let me just, it's AB, let me just name this as E, and I'll name this as F. All right, so this is, I'll just name this as O itself. All right, so if I have to find out the area of ABEO, so ABEO is basically equal to, the area of trapezium formula is basically half into the sum of the two parallel sides, sum of two parallel sides into the distance, the distance, the perpendicular distance between them. So the perpendicular distance between them, between the two parallel sides, between the parallel sides. So that is the formula. So in this case, it'll be what, half into what is the sum of the two parallel sides. So the sum of two parallel sides is basically what it is. These two are the two parallel sides. So what is the height of this? That is 6 plus 2. That will be the, one second, so it'll be 6 plus 2 into the perpendicular distance between them is basically this distance. So the perpendicular distance between them is basically how much? It is 3. So into 3 would give me the answer. So 1 by 2 into 8 into 3. So 2, 4, 8. So 4 into 3 is 12. So it'll get us 12 meter square. So that is basically, it's given as meters. So it'll be 12 meters square would be the area of ABCO. Now to find out the area of the rectangle, so to find out the area of the rectangle, I'm just going to directly do it over here. You know the formula for this, it is length into breadth. So length it'll be 6 into 2, that is 5 minus 3 is 2. So it'll give you again 12 meter square again. Now for the last one, that is to find out the area of this one, you're supposed to use the formula that is half into base into height for a right angle triangle. So half into base is 1 and the height is basically 6. So 2 3s are 6. So that will be basically 3 meters square. So what did you find out? Basically, you found out the area for the first one is 12 meter square. For the second one, we found out it's again 12 meter square itself. For the third one, it was 3 meter square. So basically add all of this value up. So what will be the total area? It will be 12 plus 12 plus 3. So that's 24 plus 3. That is 27 meter square would be the answer. Sorry, not meter square, meters. Yes. So if you found out the area, sorry guys, it'll be 27 meters, not meter square. It'll be meters. All right. All right. So the answer to this question is 27 meters. As simple as that. So that is the answer for this question, guys. So that is it from my side. I hope you guys learned something new out of today's session. I hope you guys were able to try out these questions and also got the answers right. But yes, guys, you also have a homework which I want you guys to do. So the homework for today is this, guys. In the given graph, in which time interval distance covered is maximum? So you're supposed to find out in which time interval the distance covered is maximum. This is what the graph looks like. So you're supposed to find out that particular, in which time interval the distance covered is the most. So do that, guys. Let me know what is the answer in the comment section below, and whoever gives the answer the fastest would have their name in the next session that we have. With that said, guys, that is it from my side. Thank you for joining. If you guys did like today's session, do not forget to like, share and subscribe. And if you want to if you want to get in touch with me personally, you can also reach out to me on this email ID, anoop.manoharan@vedantu.com. Thank you for joining. See you all in the next one. Take care of yourself. Stay safe. This is Anoop taking farewell for now. Take care of yourself. Stay safe, guys. Bye bye, guys. Take care. Bye bye.